We're going to begin part 3 of the 3.7 liter Jeep engine rebuild. Um, we got most of the parts in today. Certainly the bulk of them, the engine rebuild kit came in, which let us take our valve seals and our lifters to the machine shop. So hopefully in the next couple days we'll be getting our heads back. So we've got enough to go ahead and start short blocking this thing in the meantime. And so one of the things we talked about that we needed was two rods, two connecting rods, and those connecting rods, we got two new ones in. Here's an old one, here's a new one, and they are stock equivalent, but their weights aren't in balance. Whether I knew that or not, you always want to check your rods for balance. Particularly if you're getting new rods. Generally, if you have an old matched balance set, they'll stay that way unless something tore something up, but generally not a problem. So how do you go about balancing a rod? Well, first of all, what you want is you want all of your rods to be close to the same weight. Close to the same weight depends on application. If this was a racing motor, I'd be neurotic to half a gram. If this is an old banger, I may not even worry about measuring it. So this is somewhere in the middle. So we want to be within a gram or two on overall weight and on the end weight. So you've got two things. You've got, like I said, the overall weight. How much does the rod weigh? And then secondly, you have how is that weight distributed across the rod? And basically center of gravity. Where's the center of gravity of the rod? If they're not all in the same place, even at the same weights, they'll throw an imbalance into the motor, and that's something you don't want. So I'm going to begin by showing you how I go about this. Now there are machines, equipment available to balance a rod as far as the weights go. I'm using a couple of boards here, clamp. I've got some pin marks, one here, some over here on the scale. And I'll show you why in just a minute. I've got my white marker board here, and this is where we're going to track our weights, and then each of the rods is numbered 1 through 6. So if I begin here, we want to place them on the scale in a similar fashion so that we get reproducible results. You switch this over to grams. So that one's weighing 600, that's number 6, stacked backwards 6, so that's 614 grams. So overall weight for that rod, 614 grams. Number 5, 615 grams. Number 4, 612 grams. Excuse me, what was that number? They're out of order, aren't they? Yep, that was number 3. So number 3 was 612. And number 4 is 614. Number 2, 617 is one of the new ones. And number 1, 614. Now, I can tell you originally the new rods, one of which is 615, one of them is 617. I already ground on those some because I did some preliminary measurements just to get them in the ballpark. But these two, you can see we got anywhere from 612, mostly 614s. Spec according to the manual is 612. So we're going to aim for about 614 on the overall weight. Now, you can't just go start grinding on the rod to get it down to 614 grams. You need to make sure that that weight is in balance. That weight is, the center of gravity of that rod is correct. How do you do that? Well, like I said, there's some fancy equipment to do it with, but we do it the poor man's way. And what I've got here is I've got a board that's holding us up off the bench just to keep it so that the rod's relatively straight. And I have marks and a stop. I have a stop here so we know that the rod's in the same place every time. And then I have marks on both my scale and on my board so I know that it's in the same position each and every time, each and every one. We don't need an absolute weight. We need a comparative weight. We need to know how the new rod compares to the old rod. So this one says 135 grams for the end weight, and that's number 1. So then we're going to go right back through them and we'll do the same thing all over again. And again, we're going to make sure that the rod is aligned with the marks. It's pushed up against the wooden stop back there, and it should give us reproducible values. So number 2 is 140 grams. It's considerably better than they were when I started them, because I have ground a fair amount off of these rods. Can't get my words right here. Off of these rods already. This one is 136. So we're not looking for an absolute value, we're just looking for a relative value. How does it compare against the others? $135. So if you look, these are the new ones right here. So far, those that were in the engine to start with, the originals, they're all right at 135 to 136 end weight. It's a new one, 141. And then the last one, number 6. $134. So 134 to 136, that's the weights of the current rods, and then the new ones 140, 141. Now overall weight, they're getting fairly close. So if I go in here and I take off, say I want to get to 136 from 141, I'll take off 5 grams. That's going to take this rod to 610 overall. So we're not going to go there. I mean, we could actually balance all this end, and then we'd have to come back and balance the opposite end to get the weights exact again. I don't want to go below 612, that's spec. So we're going to go ahead and take off from this end, this 141, till this gets down to 612 at the lowest. That'll take this down into the 138, 137 region, and that's going to be pretty good considering the other weights. Same thing here. If we take this one down 5, that'll take us to 612. That'll take us down to 135. It'll be reasonably in balance. So how do you go about that? We do it with just a belt sander, tabletop belt sander, and basically what you're doing is you're shaving off some of this end cap. Now you got to be careful. You don't want to shave too much. You want to look here and make sure that you maintain adequate thickness. So I would rather be a little out of balance, a little, than to take off too much here and then regret that later. So we're going to go ahead and sand on these in a minute, and then we'll come back and we'll get our final weights on them, and I'll show you that when we do it. Alright, so we have worked on the new valves, valves 2 and 5, and so if I'm going to erase these numbers now and see where we land. I think they're quite right yet, but they may be as close as we get. So if we go for a total weight on number 5, that's 611. It's okay, as light as we want to be though. 611. And then we check the end weight. The little end weight, we're at, sorry, my alignment right there, 138. About 174 would be pretty close. And then if we look at number 2, we've got a total weight of 612. Yeah, I realize these things start at 622. So we've taken off a fair amount of stuff to get down to this weight. So if it's not perfect, it's certainly better than it would have been otherwise. So this one is not lined up. Now this one's also about 138. So jumping a little bit there, but 138. So what have we got? Pretty much got them where we want them. Yeah, 137, 138. Pretty much have them where we want them as far as the overall weight goes. 612, 611. And we've got anywhere between 134 and 138. 138 is the highest. So I am quite comfortable that for a motor of this class of motor, we are more than great on balance for the con rods. Now understand that this is primarily an issue associated, not exclusively, but largely associated with RPM. So if you're building a high RPM like a race motor, this becomes a larger issue than it is for us on a motor that's, you know, redlined at 5,500, 6,000 RPM, whatever it is. So we're doing well. Bottom line, don't just go by connecting rods, hope they're close to right. Go by connecting rods and make sure they're right, make sure they work out correctly. I didn't cover it, but I did check with a bore gauge. I did check to make sure that these, both in the internal diameters were correct on both ends, and then I also checked to make sure that the distance, centerline distance, was correct. So they are as they were advertised, correct for this motor. Just a matter of the weight was off a bit, not uncommon. So that's how you go about balancing connecting rods. We're going to start from here and start. We're going to clean up these rods now that we've ground all over them, but then we're going to start assembling the pistons, get the pistons made up, ready to go in, and then we're going to move on to balance shaft installation. So get right back. Well, the next thing we're going to attack is the rings. We're going to check the rings so that we can get to building those pistons, putting the pistons, rods, rings, everything together. In our case, our parts came in the bag that says first. The other bag says second. These are compression rings. Then the oil control rings and the oil control separators are in another bag that says oil. So we're going to begin with first. We'll begin with the first compression ring, and what I'd like to do is just put it into the piston. Now what we're looking to do here is we're looking to check the end gap on the ring, and that's basically, if you can see it from your altitude, there's a gap right here where the two halves, or the two ends meet. See, here it's quite large. And once we install it into the piston, into the cylinder, it closes and leaves a small gap that can then be measured. So this is the first compression ring, which is the top compression ring. This is the second, and then over here we're going to check our oil control rings. Now to check this gap, you can use a simple feeler gauge to do that with, but one thing you want to be sure is that your ring is square in the bore, and that it's below the top lip of the bore. Top lip of the bore can sometimes be a little odd sized, just because, particularly in a used motor, just because of the nature of wear. So we're just going to, what we've got here is one of the old pistons, and I've stripped the rings off, except I left the second compression ring on there, and we're going to use that just to gauge us. We're going to just push this thing in there until that compression ring bottoms out on the deck of the head, and that should be square and not at the very end of the bore. It's a good ½ inch down in there or so. Yeah, whatever, close enough. And we'll also do one of our oil wiper rings. Oil wiper rings are very different. They're actually quite malleable compared to a compression ring, and also their allowances are generally quite large. Compression is the key to success. The oil wiper ring's not unimportant, but you've got two of them. Their gaps are offset, so you're going to wipe oil off the cylinder. And the point being there, you want to wipe that oil off the cylinder so it doesn't burn in combustion in the chamber. So we know, because we have a manual, a good factory manual, we know what our allowances are. Our top compression ring can be anywhere from 8 thousandths to 14 thousandths. Second compression ring, 15 thousandths to 25 thousandths. And then, as I stated before about the oil control ring can be anywhere from 1 thousandth to 30 thousandths of an inch. That's quite a bit. So we'll check that. What I usually do is I just get the upper and lower limits on a feeler gauge here. For example, our top compression ring, 8 thousandths to 14. So if I come here, here's an 8 thousandths, here's a 14 thousandths. If the 8 thousandths will go into the gap, and let me see if it will. It does. If the 8 thousandths will go in and the 14 thousandths doesn't, which it does not, then that says that we are within range for that particular ring. So then the same thing would hold true with this second compression ring. Second compression ring, anywhere between 15 and 25 thousandths. So if we check it, does the 15 thousandths go in? Yes, the 15 thousandths goes in. Does the 25 thousandths go in? And the answer to that one hopefully is no. It's no. So that gap, we don't care really what its size is, as long as it's between our allowance, and it is. And then the same thing if you go over here to the, I think I set this one in there, didn't I? You were watching me, you should know. So I've got that one in there now, and it's just got to be between 9 and 30 thousandths. So, I mean, we can check that with this. We've got an 8 easily available here, and the 8 goes in all the way to the wall. Let's see, let's just check it for fun. Here's a 14. Yeah, see, the 14 won't go in the gap. So it tells me it's less than 14. It's more than 8. So it's going to fall within on the allowance. We're going to check a good handful of these. I like to check kind of a random sampling. I don't necessarily check them all. In my opinion, if the manufacturer got it right once, he probably got it right most all the time. So, but again, we do a random sampling. I'll do, I don't know, 3 or 4, probably 3 sets at least. And if we're good, then we'll move on and call them good. If not, to grind them, then we'll get back to showing you how to grind them. I don't expect to have to grind them. Generally don't on these stock rebuilds of these motors. So let me move forward to the next thing.